Hi, Mr. Wright here, and welcome to this film in which I'll walk you through 11 past IGCSE questions on polygons. So, to tackle these questions, you'll need to be familiar with calculating interior and exterior angles of regular polygons, also calculating the angles at the centre of regular polygons. You'll need to be able to work out the sum of the angles in a polygon, and then you'll need to be able to use all of these techniques to solve problems. This is a relatively straightforward IGCSE topic as long as you've got your head around the basic techniques. So good luck with these questions. You can download the questions by hitting the link in the description, and then you can tackle the questions before me, or you can work alongside me. You can do the questions as I work my own way through the questions in the film. If you find this film useful, please hit like. Consider sharing the film to anybody else you know who might find it useful. And of course, if you're preparing for your Edexcel IGCSE, then please subscribe to the channel. There's lots more on there to help you. And lastly, I should mention that if you've got any questions, if anything isn't clear, then leave me a comment and of course I'll respond. Or if you just want to tell me that the film was useful or not useful, then by all means, please leave a comment too. Right. Let's get on with the maths. Question 1. Right, the diagram shows parts of 3 regular polygons, A, B and C, meeting at a point. Look at that, the polygons meet there. And I see that's part of polygon B, this is part of polygon C, and this is polygon A. Polygon B has n sides. Work out the value of n. So I'm being asked how many sides polygon B has. Polygon B is this one, isn't it? Right, well, I just wonder if I can work out the interior angle here of B. Work out that 7x. It'd be nice to be able to work out what x was. Now I see all of those, the whole angle here altogether. Let me show you that. This whole angle from here all the way around, from here all the way around to there, is 360. And I also see that that's 18x. So I know that 18x is equal to 360. So if I divide both sides by 18, then I know that x is equal to 20. So now I can work out that the interior angle of B is 7 times 20, 140. Now I know the interior angle is 140, so I know the exterior angle is 180 minus 140, 40. And of course the number of sides is 360 divided by the exterior angle. So polygon B has 9 sides. It's a nonagon. And that's question 1 finished. Question 2. Right, the diagram shows a pentagon, 5-sided figure. Now I'm just having a quick look at the diagram. I'm given all of these interior angles apart from that one. And the question is, work out the value of x. Well, I'd really like to know what all the interior angles of a pentagon add up to. So the sum of the interior angles of a pentagon is going to be the number of sides minus 2 multiplied by 180. So 3 times 180. So there are 540 degrees in total in a pentagon. So I'm going to add up the angles that I know. 119 plus 67 plus 135 plus 90. 119 plus 67 plus 135 plus 90. So that gives me 410. So x must be the remaining number of degrees, 540 minus 410. X must be 130. And that's question 2 finished. Question 3. The diagram shows a regular octagon and a regular pentagon. Let's just have a think about what I know about octagons and pentagons. Now, an octagon has an exterior angle of 360 divided by 8. So an exterior angle of 45 and an interior angle of 180 minus 45, 135. And a pentagon has an exterior angle of 360 divided by 5, 72, and an interior angle of 108, that's right. So let's see what we can work out here to work out the size of angle X. Well, I know that that is the interior angle of the pentagon, so that is 108. And I know that this red angle here is the interior angle of the octagon, so that red angle is 135. So the difference between those two angles, 108 minus 135, 135 minus 108, is that angle there. So that blue angle there is going to be 27 degrees. Well, that's all very well, but how now am I going to find the angle X? That's this angle here. Well, it relies on you being sure about this word regular. You see, it's a regular octagon, so all its sides are the same length, and it's a regular pentagon, so all its sides are the same length. But the size of the octagon and the size of the pentagon are the same length as each other, because AB is the same on both of the shapes. So this triangle here, the triangle from I to C to B, is actually isosceles, because that length is the same as that one. So it's an isosceles triangle with an angle of 27 there. So that means that X is going to be 180 minus 27 divided by 2. So 180 minus 27 divided by 2. So X is 76.5 degrees. And that is question 3. Question 4. Now in this question I've got a regular octagon. And I've got a pentagon. It doesn't say it's a regular pentagon. And when I look at the pentagon, which is the shape on the right, I see the interior angles aren't all the same. So a regular octagon and a pentagon. Angle GHD is the same as angle FGH. That is this angle and that angle. Those two angles are equal. Okay, and I'm asked to find the angle X. Well, I could start off, I think, by finding the red angle. So I'll put a little red angle here to show that I'm finding the red angle. Now, that red angle, those two red angles are the same, and they're both inside that pentagon there. And I know these angles are interior angles of the pentagon, and so are those two. I know what all those have to add up to, of course. It's a pentagon, so the sum of the interior angles is going to be a pentagon 5 sides, so 5 minus 2, 3 times 180. So the total number of degrees inside a pentagon is 540. Let's subtract the angles that I know about. I know about 112, 102, and 96. So how many degrees does that leave me with? 540 minus 112 minus 102 minus 96 leaves me with 230 degrees. So each of those red angles is 230 divided by 2. So each of those red angles is 115. Okay, now I need to find X. I need to find this angle here. I know that that red angle is 115. If only I knew what this angle was here. Oh, no, wait a minute. That's the interior angle of the octagon, and the octagon is regular. Okay, so let's talk about that octagon, shall we? The exterior angle of an octagon is 360 divided by 8, 45. So the interior angle of a regular octagon is 180 minus 45, 135. So that angle is 135. Now I can find X. So X will be 360. Subtract the red angle. Subtract that angle at H, 135. Okay, 360 minus 115 minus 135 gives me an answer of 110 for X. And that is question 4 done. Question 5. I've got a 10-sided polygon, a decagon. And I'm told all those interior angles, look, I've got to work out the value of X. I'm not quite sure how to work out the value of X, but I could work out the value of that red angle, because it's the last interior angle, isn't it? Now, what's the total of the interior angles of a 10-sided polygon? 10 minus 2 is 8 times 180. 8 times 180, 1,440. So that's what all the interior angles have to add up to. So I have got I've got 9 of those interior angles. So on my calculator, I'm going to add up all these 9 numbers, and then I'm going to subtract that from 1,440 to tell me what that red angle is. So 125 plus 134 plus 168 plus 150 plus 148 plus 150 plus 168 plus 134 plus 125, 1302. So the red angle there is going to be, 1440 minus 1302, which is 138. So the angle X is going to be 360 subtract 138, which is 222 degrees. And that is my answer for question 5. Question 6. The diagram shows 2 congruent, identical, regular pentagons drawn inside a regular octagon. Okay. One side of each pentagon lies along the side of the octagon. Yes, I can see that. AB is a side of the octagon. That's this side, and it's one of the sides of this octagon here, isn't it? Okay, so I understand that. Okay, next. BC is the side of, AC is the side of one of the pentagons, yes. And BC is the side of the other pentagon, yes. And just a minute, those two are the same length, aren't they? BC and CA, because the pentagons are identical. So that's a little isosceles triangle there. That might be useful. Okay. Work out the size of angle Y. All right. Now, let's have a think. We've got a pentagon here, a regular pentagon. So I could work out the interior angle of that regular pentagon, couldn't I? Okay, well, a pentagon's got 5 sides. So the exterior angle is 360 divided by 5, 72. So the interior angle is 180 minus 72. So that interior angle there is 108. Good. Now, could I work out the size of this red angle here? I think I could, because that red angle is the interior angle of the regular octagon. So the interior angle of a regular octagon, well, the exterior angle is 45. So the interior angle is 135. Right, so that red angle is 135. So that means that this angle here, which I'll shade in blue, is the difference between 135 and 108. So it's 27. Okay, now, do you remember how that triangle, the triangle ACB, is isosceles? Well, that means that this side, this angle here, the angle at B, is also 27. So I think I can work out Y by doing 180 minus those two 27s. So 180 minus 54. 126. That's what Y is. And that's my answer to number 6. Question 7. Right, the diagram shows a triangle APB inside a regular hexagon. So it does. Now it tells me here that AB is 5, and they haven't marked that on the diagram, so I'll mark that on the diagram. BP is 2, mark that on the diagram. And the angle at B is 90, they've marked that on the diagram. So that's a right angle triangle there, isn't it? Work out the size of angle PAF. That's this angle here, so that's my target angle. Give your answer correct to 3 significant figures. Right, let's have a look. Now, looking at that right angle triangle there, and the hexagon. Well, it's a regular hexagon, so I can work out the whole of that interior angle of a regular hexagon, can't I? Let's do that down here. So it's a hexagon. So the exterior angle is 360 divided by 6, so that's 60. So the interior angle, which is the whole of that red angle, is 180 minus 60, 120. Good. Now, if only I could work out this green angle here, then I could calculate my target angle by doing 120 subtract that green angle. How can I work out that green angle? Well, let's have a look. We've got this right angle triangle here. Okay, that's the angle I'm trying to find. That's 5 and that's 2. Look at that, and that's a right angle, so I can use tan, can't I? If I call that angle alpha, then tan alpha is the opposite over the adjacent. So on my calculator then, 2 divided by 5 equals shift tan equals. So alpha is 21.801 and so on. So now to work out that target angle, which is PAF, I'm going to do the whole of the interior angle, subtract alpha, right, gives me an answer of 98.1985 and so on, and so to 3 significant figures, that's 98.2 degrees. And that is question 7 done. Question 8. All right, lots of information to read here, and check is on the diagram. I've got 5 sides of a regular polygon. That's these sides here, AB, BC, CD, DE, and EF. So that's my regular polygon there. Okay. And then I've got some straight lines, which are probably shown as straight. Look, that's obviously straight. That's obviously straight, and that's obviously straight, so that's okay. I'll get rid of all of those because I think I can understand those facts from the diagram. RST is parallel to CD. That's telling me that that line there is parallel to that line, and those are marked on the diagram as well. That's good. Angle RSC is 128, that's marked on the diagram, and so is that UCV being 32. Work out how many sides the polygon has. Well, to work out how many sides the polygon has, I really want to know its interior angle or its exterior angle. Now, here is the interior angle of the polygon. Now, there are other interior angles of the same polygon, such as that one, or that one. But the reason that I'm concentrating on the interior angle at C is that I've got some information here. Look, I've got this, and this, with RS being parallel to CD. And so I can tell you that this angle here is 128 because it's alternate with this angle. Right, so it does say show you're working clearly. So down here, I'm going to write that SCD equals 128 brackets alternate with RSC. There we go. Now, I've almost found that internal angle then now, haven't I? Now, what else can I do? If only I knew this angle here. Okay, well, isn't that angle just 32? Because isn't it vertically opposite this one here? Because this is a straight line from here to here, and that's a straight line from there to there, so it is just 32. Brilliant. So now, I better write that down since it wants me to show my working. SCB equals 32, vertically opposite UCV. And now I've got the whole of that interior angle, haven't I? So now I can say that BCD equals 128 plus 32. That is what is that? 128, it's 160, isn't it? So that's the interior angle. So the exterior angle of the polygon is 20. So the number of sides is 360 divided by the exterior angle. 360 divided by 20, it has 18 sides. And that is the answer to question 8. Question 9. Right, I've got a 9-sided regular polygon. Okay, with a centre O. And there's a triangle drawn there. Let's not fall into the trap of assuming that that's a right angle, because we're not told it's a right angle. Okay, and we've got to work out the value of x. Right, well, we've got a 9-sided polygon, so let's just write down what we know about our 9-sided shape. The exterior angle would be 360 divided by 9, so the exterior angle is 40. So the interior angle is 180 minus 40, which is 140. Now, of course, the exterior angle is 40, and so is the angle at the centre. All right, let's focus on this triangle here and see what we can find about that triangle, because what I'm kind of thinking is if I can find this angle, and if I can find the angle at O, then I can obviously find x, because it's 180 minus those two. Okay, now let's have a think about that. Well, if you're used to spotting angles at the centre, then you'll see that the whole angle here is 2 angles at the centre, isn't it? So that whole angle there is going to be 80 twice 40. So that's looking good. Now, what about the angle here, which I'm marking in green? What about that angle? Well, that angle is half of the whole of the interior angle. Look, that's the whole of the interior angle, and so that green angle is half of it. So the whole of the interior angle was 140, so that green angle is 70. And now I can find x. X is going to be 180 minus 80 minus 70. So x is 30 degrees. And that is question 9 sorted. Question 10. Right, I've got a regular 10-sided polygon here. And then I'm asked to show that x equals y. Let's just first of all have a think about the 10-sided polygon. What do I know about a 10-sided polygon? Well, the exterior angle is 360 divided by 10, 36. And the interior angle is 180 minus 36. So that is 144. Now let's have a look at x. I see that x is part of a shape on the left there. And look at this, I've got that's 144, that's 144, that's 144. Now also, of course, this is x as well. So let's just concentrate on this yellow shape here. Now, if I knew the total number of degrees in that shape, then I could take away the angles I know, those 3 144s, and split the rest between the two x's. Now, well, wait a second, that yellow shape, it's got how many sides? 1, 2, 3, 4, 5 sides. So the yellow shape has a total number of degrees. The number of sides minus 2 times 180. Its total number of degrees is 540. And so x is going to be 540 minus those 3 144s. And then I'll divide that by 2 to find x. Right, bit of calculator action. And I find that x is 54. All right, so x is 54. Let's make this really clear and just say x equals. And let's say x. Right. Now, how can I find y? Let's have a look. Let's get rid of all that now. I've done all that. Good. How can I find y? I'm not quite sure how to find y. But having found x by looking at the shape on the left, if I call this angle z, I'm kind of thinking, can't I find z the same way as I found x? Except this time, I'll look at this blue shape here. Now, each of these angles is 144 again. There you go. I've got 2 144s, haven't I? Now that blue shape Again, that's Z. That blue shape there, it's got 4 sides. So the total number of degrees in a quadrilateral is 360. So I'm going to do 3, so Z is going to be 360 minus the two 144s. And then that's going to be divided by 2. So that means that Z is 36. Right. Okay. So we've got 54 for X, 36 for Z. So how can I find Y now? Well, Y will be the whole of that interior angle, the whole of A. So Y is going to be 144, the whole interior angle. Take away 36, take away 54. Let's work that out. 144 minus 36 minus 54. Look at that, I get 54. So I can say that X is the same as Y because they both equal 54. And there we are, I've shown that X equals Y. And that is question 10 done. Question 11. Right. B, C, D, E, F, G, that's this shape here. That shape there is a hexagon. It's got 6 sides, and we could count those to check, but I'm sure they're right. And then it tells you that AB, BC, and CD are 3 sides of a regular n-sided polygon. I'm sure that's supposed to say n-sided there. Okay. So those 3 sides are part of a polygon. Okay. I need to find the number of sides of the polygon and calculate the value of n. If only I could find the interior or the exterior angle of that polygon. There's quite a tempting interior angle of my mystery polygon there, isn't there? So I'm wondering if I couldn't find this red angle, because that would enable me to find the green angle. How can I find the red angle? Well, the answer is that the red angle is one of the interior angles of the hexagon. It's one of the interior angles of this blue hexagon here. Now, I've been given lots of angles of that blue hexagon, except actually that angle at C. So why don't I work out that angle at C, and then I can do 360, take away that angle at C to get my green angle. Let's have a look. So it's a hexagon, isn't it? So the total number of degrees in a hexagon is the number of sides minus 2 times 180. Sorry, the number of sides minus 2 times 180. So that's going to be 4 times 180, 720. So this angle here at C is going to be 720 minus the other interior angles. So minus 57, minus 104, minus 149, minus 95, and minus 90. So that angle is going to be 720 minus 57 minus 104 minus 149 minus 95 minus 90. That angle is 225. So that means that this green angle here is going to be 360 minus 225, 135. So the interior angle of my shape there is 135. So the exterior angle is going to be 180 minus 135. Okay, so the exterior angle is 45. So now I know the exterior angle of that shape. I can find the number of sides by doing 360 divided by the exterior angle. Let's have a look. 360 divided by 45. It's got 8 sides. It must be an octagon. And the answer is that n is 8. And that's question 11 done. Well done. That's it. That's 11 past IGCSE questions on polygons. If you've got any questions, please leave them in the comments and I'll respond. Please also leave me a comment. Tell me how you found the film. What was useful? Are you finding my films useful in preparing for your Edexcel IGCSE? Do hit like, do share the film. And of course, if you're preparing for your Edexcel IGCSE exams, then subscribe to the channel. There's lots more to help you. Right, thanks for watching. See you in the next film.